All right. Hi, everybody, and welcome back to part 2 for a deep dive on data internals. Forgive me, I'm a little bit under the weather today, so hopefully my voice holds out all the way through this presentation. I'm going to pick up exactly where we left off on our previous presentation. Previously, we had made it through data internals for a record, and we were going to go next to pages. So we're going to pick up right here on the same spot of our slide deck. I've got a lot of information and a lot of demos, hopefully, that will make internals applicable to the real world. So we're going to try and hit the ground running with this right away. Now, as a reminder, my name is Bradley Ball. I'm SQL Balls on Twitter. My email address, and let me show this one more time before we dive into it. Typically, I'll do an introduction slide. And this is me. These are some ways you can get in contact with me if you have any questions after. I appreciate the emails that I got last time as well. bball@pragmaticworks.com. Always a great way to get in touch with me. Depending on how busy my day is will depend on how quick I can get an email back to you. But I promise you I will respond. And some of the cool things I've done, my experience. But if you were here for part 1, then let's go ahead and dive all the way right on to part 2. As you recall, what we've been discussing is the way that we learn backwards. And as you can see by the slides that I'm passing by right now, we covered a lot. This deck is currently on my website. If you go to sqlballs.com, my resource page, you can grab it, and we've already got the presentation from this Tuesday up and online. So please feel free to go and grab that and begin streaming that if you missed anything on record internals. So to pick up from pages, we started our data hierarchy. At the very bottom, we've got records. Our next step up is pages. When we look at the anatomy of a page, the way that a page is put together is it is 8,192 bytes, and the first 96 bytes are our page header. Inside of our page header, we have a lot of metadata specific to our page. As you can see, I've got a little excerpt in there in yellow. You can see, for example, one of the things I have highlighted is M-free data. This points to the next location on a page where our next data record would get inserted. Now, this is important because later we're going to talk a little bit about latches, and you'll see how M-free data and page metadata correspond directly to latches within SQL Server. Inside of our page, we have 8,090 bytes that we can actually store data on and also have our slot array. Our slot array is a zero-based array that records the number of records on a page. When we use DBCC page and we go and we look at the data on a page, one of the quickest ways to be able to tell how many records you have on a page is you can either look at the slot count, the M slot count up at the top, and you can see for this instance I only have 3 slots, and this page only had 3 slots on it as well, or you could scroll all the way down the bottom. As a zero-based array, our first record is going to be 0. We add +1 to that, and you'll be able to figure out how many slots that you actually have on a page. This is important because our data records could actually be pushed in a different order than what we would believe them to be based off our clustered index key, based off of the way that we think they might be located on the page. It's going to be basically based on insert ratio if it's a heap. The slot will actually point to that space within these 8,096 bytes that shows us specifically where we can get the data as we're looking for it. There are a lot of different types of pages. The most common type we're going to find is a data page, and that's what we were looking at previously. When we look at DBCC IND previously, we were looking at page types. Page type 1 was a data page. Page type 2 is an index page, and you can see right here, that's the second one on our list. Whenever you create an index, a clustered index or a non-clustered index, you're going to get type 2 index pages. In a non-clustered index, every single page will be an index page. A non-clustered index will have leaf pages down at the very bottom, the 0 level of an index. This is going to be where the actual data for a non-clustered index is stored. If you put any include columns on your leaf level of your pages, those will be on index pages for your non-clustered indexes. Any non-leaf level pages would be our intermediate level and also our root level for indexes. All pages that are above level 0 essentially. The next type of page we have is a text page. Now remember, we were talking about records and records have different allocation units for where they are stored. Anything that is 4,000 characters or higher that cannot fit on a regular data page is going to be on a text record, either as a lob data or a slob data page. Slob data is also known as row overflow data. Lob data is large object data. And these are going to be in a text tree format. We'll have a 24-byte pointer in our regular data record that points to these pages to be able to get these larger text records. But this is how we can associate, say, a 2 gigabyte var binary or a 2 gigabyte varchar max field with a regular data record that we've got on our data pages. We also have sort pages. Sort pages are created in TempDB, typically when we have an order by operation or if we have a merge join operation. We could have a spill to disk, which will be identified in our query execution plan, and it'll let us know that we have a spill operation. Sort is going to be sort pages are created whenever we have to order something, though, and it's not physically ordered that way on disk. For example, if we've got a student table and we've got a student ID as our primary key, if we decide we want to select all from students and we want to order by their birth date, or we want to order by their first name, last name, or last name, first name, we're going to need sort pages created to be able to take that data, sort it in a particular order before the storage engine can hand it back to our relational engine. We have a boot page. Boot page is always page 9 in every single database. This is where when your database first comes online and it boots up, a lot of the metadata is stored on boot 9 of the page. As a matter of fact, in transparent data encryption, we actually have this in the file header, page 1 of the page, which is a thumbprint to be able to check that the database has the proper encryption key. So our file header page is page 1, and that page is always loaded up first. And it's a very important page because, again, if you're using transparent data encryption, this is where we check that header to make sure that we've got the matching thumbprint certificate to be able to decrypt the file. Allocation pages, we have GAM pages, SGAM pages, PFS pages, diff map, ML map, and IAM pages. And we're going to go into those just a bit more in a moment. So next up, because we've covered pages, the important thing about pages is understanding the different types of pages that we have in our database.